Hello everyone. In this video, we will be discussing what is TensorFlow, why it is needed, and we will also look into few basics related to it. So let's begin by understanding what is TensorFlow. TensorFlow is a software application popular for implementing machine learning algorithms, in particular for deep learning. TensorFlow was created by Google Brain team and it is an open source library for numerical computation and large-scale machine learning. TensorFlow bundles together a slew of machine learning and deep learning models and algorithms and makes them useful by way of a common metaphor. It uses Python to provide a convenient front-end API for building applications with the framework while executing those applications in high-performance C++. High-level APIs like TF layers, Keras, and PrettyTensor can run on top of TensorFlow. TensorFlow can train and run deep neural networks for handwritten digit classification, image recognition, word embeddings, recurrent neural networks, natural language processing, and partial differential equation based simulations. Best of all, TensorFlow supports production prediction at the scale with the same models used for training. Now let's see why TensorFlow. The biggest benefit TensorFlow provides is abstraction. Instead of dealing with the details of implementing algorithms or finding out proper ways to hitch the output of one function to the input of another, the developer can now focus on overall logic of the application. TensorFlow takes care of the details behind the scenes. TensorFlow has better computational graph visualizations, which are inherent when compared to other libraries like Torch and Theano. TensorFlow provides both C++ and Python APIs that makes it easier to work on. With these APIs, we do not have to really go deep into writing all the stuff that is required. Let us say if you want to prepare a neural network or to configure or program a neuron, all you need to do is to call the API and pass the data. That is pretty much sufficient. TensorFlow supports both CPUs and GPUs computing devices, and it has a faster compilation time than other deep learning libraries like Keras and Torch. How does TensorFlow work? TensorFlow allows developers to create data flow graphs that describe how data moves through a graph or a series of processing nodes. Each node in the graph represents a mathematical operation, and each connection or edge between the nodes is a multi-dimensional data array or tensor. Tensor provides all of this to the programmer through Python language. Python is easy to learn and work with, and also provides convenient ways to express how high-level abstractions can be coupled together. Nodes and tensors in TensorFlow are Python objects, and TensorFlow applications are themselves Python applications. Types of APIs TensorFlow provide. There are two main APIs that TensorFlow provides. The first one is TensorFlow Core API. These APIs are used for low-level machine learning development. And the second one is high-level APIs. These are more compact APIs such as tf.contrib.learn or tf.layers. TensorFlow Core API provides a complete programming control. It is more suitable for machine learning researchers and others who require fine levels of control over their models. High-level APIs are built on top of TensorFlow Core. These are easier to learn and use than TensorFlow Core. They make repetitive tasks easier and more consistent between different users. High-level APIs such as tf.contrib.learn helps you to manage datasets, estimators, training, and inference. What are tensors? Tensors are multidimensional data arrays or inputs and outputs of TensorFlow. Tensors help you to store and handle the data in compact way during computation. They are a set of values shaped into an n-dimensional array with static and dynamic type dimensions. They mathematically represent a physical entity characterized by magnitude and multiple directions. They typically contain floats but can carry strings too in the form of byte arrays. They may be passed between the nodes of a computation graph and have a data type. There are some terms associated with tensors. Let's have a look at it. One is dimension and the other one is rank. First, let's understand what is dimension. Dimension is nothing but the number of elements in the array. For example, this is a 4 by 5 dimension tensor. And you have multi dimensions, right? And this can be 3 by 3 by 3. So that is the dimension. Tensor rank. A tensor's dimensionality can be described using rank, shape, and dimension number. Tensor's shape and dimension determines its rank. The rank of tf.tensor object is its number of dimensions. Number of dimensions plus shape determines tensor rank. Tensor rank is supposed to be 0 when there is only one element and we call them as scalar. If you have one dimensional array or a vector, then the tensor rank is 1. Similarly, if you have two arrays, then the rank is 2, and if you have three arrays, then the rank is 3. Computational graphs. TensorFlow operations can be arranged into a graph which is termed as computational graph. It enables creating very large-scale neural networks as computing can be distributed over several CPUs and GPUs in a similar fashion. Computational graph is the graph of program logic which TensorFlow builds in the memory. It demonstrates how variables are defined and operations are performed on them to solve the desired function. The actual execution of the graph comes in steps that follow later. The computational graph can be broken into chunks and can run across many different CPUs and GPUs parallelly. This is called parallel computation. As I mentioned earlier, each node in the graph represents a mathematical operation like addition, subtraction, etc., and each edge between nodes is a multidimensional data array or tensor. Development of TensorFlow across the years. TensorFlow 1 is one of the most widely used deep learning packages. It is very versatile and that is why many practitioners like it. However, it has a major disadvantage, that is, it is very hard to learn and use. This led to the development and popularization of high-level packages such as PyTorch and Keras. Keras is especially interesting as in 2017 it was integrated in Core TensorFlow, a feat that may sound a bit strange. In reality though, both Keras and TensorFlow are open source. Keras author claims that Keras is conceived as an interface for TensorFlow rather than a different library, making this integration even easier to digest and implement. However, even with Keras as a part of TensorFlow, TensorFlow was still losing its popularity. This was addressed in 2019 when TensorFlow 2.0 came on the horizon. It is TensorFlow's effort to catch up with the current demand for high level programming. Interestingly, instead of creating their own high level syntax, the TensorFlow developers chose to borrow that of Keras because people generally love Keras. In fact, TensorFlow 2 has the best of both worlds, most of the versatility of TensorFlow 1 and high level simplicity of Keras. And that's not all. There are also some major advantages of TensorFlow 2 over TensorFlow 1 like simplified API, no duplicate and deprecated functions, has some new features in core TensorFlow. What's important to us is TensorFlow 2 boosts eager execution, in other words, allowing standard Python rules of physics to apply to it. So that's it for the video guys. If you like the video, please do like, share, comment and subscribe to the channel. And until next time, have a good day and happy learning.